You type 3 letters into your contacts and your phone finds one name out of 10,000 before you even finish typing. It didn't search through them. Searching would be too slow. It jumped straight to the answer. This is a hash map, the quiet engine behind almost every fast app you've ever used. Once it clicks, you'll see it everywhere. Here's the problem it solves. Say you have a million users and you need to find one by their email. Checking them one by one could take a million steps. Even binary search needs the list sorted and still takes about 20. A hash map finds it in 1, not 20. 1, no matter how big the list gets. The trick is to stop searching for where your data is and start calculating it. You take the key, the email, and run it through a function called a hash. That function turns the key into a number, and that number is the exact slot where the data lives. Think of a coat check. You don't scan every coat to find yours. You get a ticket with a number and walk straight to that slot. The hash is that ticket machine, same key in, same number out every single time. So to store a user, you hash their email, get slot 4217 and drop them there in an array. To find them later, you hash the same email, get the same 4217 and jump straight to it, one step. That's why it feels instant. 100 items or a billion, the work is the same. Compute the slot, go there. Binary search shrinks the problem by half each time. A hash map skips the searching entirely. But there's a catch, and it's the thing interviewers love to ask about. What happens when two different keys land on the same slot? That's called a collision, and it will happen. It's like two people handed the same code, check number. You can't just throw one of the codes away. The common fix is chaining. Each slot doesn't hold one item, it holds a tiny list. Collide and you just add to that slot's list. To find something, you jump to the slot, then scan its short list. As long as those lists stay tiny, lookups stay basically instant. And they only stay tiny if the table isn't too full. So when it fills up, the map quietly doubles in size and replaces everything. That resize is the secret to staying fast even as it grows to millions of items. You are using this constantly. Every JavaScript object, every Python dictionary, a hash map underneath. Databases use them to jump to a row without scanning the whole table. Redis is basically one giant hash map in memory. Counting things, removing duplicates, catching results, all of it is one hash away. Now, two things that quietly fail people in interviews. One, a hash map is old on average, but old in the worst case. If every key collides into a single slot, you're back to scanning a list. A good hash function is what prevents that. 2, your keys must stay stable. Change a key after storing it, and the map looks in the wrong slot and never finds it again. So whenever you need to find something instantly, stop asking, how do I search this faster? Ask instead, can I compute exactly where it lives? That question is a hash map. The number one data structure interviewers test after arrays. If this finally made it click, the whole DSA Visualized series is for you. Follow Tech Tracing and I'll see you in the next one.